Anyone want to answer, give some thought on the Zoom chat? I think everyone is shy. Okay. Uh, in this case, the answer is only one, not like the previous one. The previous one is like depending on the use case. But in this case, because it is related with the safety, so we should prioritize recall. Why? Because if we missing one real safety incident, it could result in a serious injury or even death, and this is unacceptable. So we should prioritize high recall instead of high precision, or maybe balance between recall and precision. Recall is the only one right answer. False positive in this case may cause inconvenience from the user, but it can be like follow up manually. For example, like just to make sure, are you we build a feature that pop up notification, are you okay, or what, and then the user can just click a button, yes, I'm safe, to understand that, oh, this is the 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 result of the alarm is not true. But the one thing that I want to highlight is in life critical system, in safety system, it is far more important to catch everything, even it is means to over alerting. Because in safety related machine learning, we always care about recall. It is okay to over alert if it is means we never miss something serious. So that's about the basic of the machine learning, supervised, unsupervised, and also the evaluation metrics. And maybe I will talk more about the more use case that I already applied in my role. So actually, this is just a simple question, a sample. For example, there is a business question. If you are a Grab user, then you will understand there are some of the taxi type in the Grab, such as like GrabCar Hemat, Grab Bike. There is also a new product which is GrabCar Premium, which offer you a high-end vehicle or maybe a newest vehicle as well. So because we just launched this product and we want to understand about, did this GrabCar Premium increase our user satisfaction or retention? That's a question delivered to the data team. And how to address this answer. And then from our side, from data side, we might maybe from the general person, they will just suggest you can you can try to find out the like the GMV spend or the number of transacting user for the GrabCar Premium user compared to non-GrabCar Premium user. Just as simple as that. But we cannot do that. Why? Because if we just barely comparing the premium user to non-premium user, it may have very different behaviors. First, maybe the premium user is still small, maybe like 10% of all of the population. So if we compare the 10% to the 90 to the rest 90%, it might be biased. So we cannot do a direct comparison between premium user and also non-premium users. So how to answer this question? And then the one of the machine learning methodology that we usually use is called PSM. It is I will share what is PSM later, but basically we want to finding a non-premium users who behaves like a premium user before we offer the service. So the goal is to make a fair comparison by controlling for confounding variable that influence user behavior. So we will not comparing a premium versus non-premium user directly, but we will find out a set of users that have a similar behavior with the premium users. So the comparison will be more fair. And this is a PSM. Basically, PSM is propensity score matching. This is a combination between, this is a supervised learning. This is combination between, this is a combination between supervised and unsupervised learning. Basically, the propensity score matching is a quasi-experiment method to estimate a causal effect from the observational data, and it attempts to reduce selection bias by equating groups based on observed covariates. Imagine you have this 100% of population with varying of characteristic, varying of behaviors, and etc. And when you apply the PSM, you will find the cluster of the group, and then you can put it as a control because we already have a treatment, which is in this case is the user that already use a GrabCar. And yeah, this is the goal of the PSM. And how does it works? So basically, we will apply a score user based on the likelihood to the user that already use the GrabCar Premium, which is we call this as propensity score. And after we got after every user has their own score, then we will do a match between premium user and with non-premium user with the similar scores. And then after we already get a set of treatment data and also the pseudo control data user, then we can compare the outcomes like maybe retention, satisfaction scores, or rebooking rate, and etc. So here's the first thing. First is to estimate the propensity score. So we usually use a classification model to estimate the probability that a user receive a treatment. In this case, is using a GrabCar Premium. Usually we are using these commands of machine learning algorithm. But the most common one is logistic regression. Why? Because the output is we want have score between 0 and 1. And if you familiar with the logistic regression, the output is like logistic logarithm curve, and it is false between 0 and 1. That's why logistic regression is the most standard one to run a propensity scores. And after each user has their scores, then we do a matching. And in this case, we will match each premium user with one or more non-premium user based on their similar propensity score. And in this section, we will apply the clustering method. The most common one is the KNN, nearest neighbor, nearest neighbor. And to do this, we need to do some feature engineering because to get the output of the classification model, we need a lot of feature, right? And to do this, also we need to understand about the business context. For example, maybe we can use how is the frequency of ride for each user? How is the average fare spend? How is the location activity for each rides? Maybe we can also put the device type, what is the usual payment method, and etc. We can put all of this variable into our feature to be in our model. And yeah, this part also very interesting to explore because each use case might have different variable, different feature engineer. Yeah, and then after we get the propensity scores, get the matching, and we do the balance check. Usually we will check how is the SMD of each group. are they to vary across each other? Are they is already like in the balance SMD? This is very important to find out that our prediction is good enough or not. And after that, we can compare by running a statistical test like the test or just difference in means to estimate the treatment effect. So after we do those steps, then we will get the after matching set of user, which is the difference between one and other might be more less than before we do a matching. And before we do a matching, we obviously will lead to biased data because the behavior of premium and non-premium is very, very different. That's why we need to do this kind of methodology to find the pseudo control user. So the outcome will be clearer measurement. Maybe this diagram is more helpful for you to understand about how does it works. So first, because the PSM consists of running a propensity score and then do a matching. So this is the supervised learning. The input is we want to scoring each user ID to have a score between 0 and 1. And then after they got a result, they got a score, and we do a clustering to do a matching between one premium user to non-premium user, but with similar score. For example, like this, and we will match 1-1. And yeah, the output is the one treatment packs with one corresponding pseudo control packs. And how to like get the set of data of this user? Usually, let's say we applied the GrabCar Premium on September 2020. So during the performance period, let's say for 4 months, we already have a set of user ID that experience or have a booking of premium rights. So we have a base of user ID with premium use case during this post period. Then how to get the user the user who has no experience with the GrabCar Premium? Usually we will look back to the previous period to find a matching to do the PSM in the previous period. So we will do a pseudo scoring using this base period to find out the user that not in this performance period. I mean that not experienced with GrabCar Premium, but within this period. And why we do a matching between this pre-period? Because it is not affecting with the event that we applied in here, which is they not exposed yet with the GrabCar Premium. That's why we do a PSM matching in the pre-period. And yeah, we do a matching, we do a propensity score based on, for example, these features, and got the propensity score, then do a clustering, which is matching the one treatment to the one pseudo control. Then yeah, that's it actually. So from this, we can get a clear result of calculating the impact of the premium, in this case, to find out the uplift of the retention. And then the other use case is using the cosine similarity. This is also a machine learning approach. From my experience, so I have actually this is a simple one. So back then we have a very messy data about the vehicle name. For example, here the right name is Toyota Avanza, but because back then the input is a free text, So sometimes the user input it as Toyota Avanza. So there is a typo here. Daihatsu Xenia become Xenia using S. Suzuki Ertiga become Suzuki Ertiga, something like that. It is very, very messy. Then it is very hard to us to actually this data point is very important also for our other use case, but we need to clean it up. That's why uh, I was trying to do some cosine similarity using TF-IDF also, so we can fix the typo name into the right one. And the goal is, yeah, we have a standardized name for all of the vehicle names. Basically, the idea is uh, using NLP model, we will measure how similar two texts are, even they are not exactly the same. So we will build a vector uh, using TF-IDF, and then calculate the vector between those words. And before that, we also need to do some pre-processing data, like make sure that the lowercase is make sure that the words is already in the similar patterns, like do a lowercase, remove all extra spaces and etc. uh the hardest part to do the text analysis is basically in the pre-processing. And after all the pre-processing is done, then we running the TF-IDF, compute the cosine similarity, and yeah, we got the more clean data after we compute all of this compared to the raw data one. Yeah, that's about the cosine similarity use case. And maybe it is the last one. So basically, this is about time series also really, really important in the industry. For example, last year, we know that there is a Taylor Swift concert in Singapore. And because of this, imagine that Taylor Swift has a concert only one in the Southeast Asian. So many people coming from Indonesia, Malaysia, and other neighborhood country will coming to the Singapore, and that this event makes all of the transaction become spike because many of traveler coming to Singapore, and we want to find out the impact of the Taylor Swift concert on the Grab car rides, for example. And actually, we cannot directly tell that during the Taylor Swift concert period, the uplift is, for example, 30%. We cannot do that because the 30% is like it's not a real uplift of the events, but we need to estimate some of the seasonality as well. So that's why we are running a time series to answer the real impact of these events. Usually we will use the BSTS, which is the Bayesian structural time series model, because it can help us to estimate the counterfactual, which is what would have happened if the concert didn't take place. So this time series model is uh, can account for seasonal trends, time varying effect, and also some external factor. So basically the outcome will be something like this. Why and when we need to use this model, basically when we want to understand the overall impact of a particular event across the entire user base. And this is also applicable when the intersection is affect all of the individual across groups and user. For example, in our case is Taylor Swift concert. It is a massive one in Singapore during that period. So yeah, we can use this approach to calculate the actual impact. And why we don't use the PSM? Why we don't like use a A/B test or another approach, because in this case we cannot do that, because this event is applied, because it is a massive things that happen within a period of time. So time series is the best approach to answer the business question. And actually the outcome will be something like this. So the after we compute the time series things, obviously we need to do some feature engineering as well, similar as my previous explanation in the PSM. But in the end, the result of the time series usually will be like this. You imagine the orange chart is, sorry, the blue one is the predictive result of the time series based on our model. And then we will calculate the error for the pre-period, which is in the before the red vertical axis here. We calculate the error, and then this is the post period, which is the Taylor Swift period of concert. We can see that during this period, the orange one, which is the trend if the concert is not taking place. So if there is no concert, so the prediction of the data trend will be the orange one, but the actual one is the blue one. So we can calculate the uplift between the blue and orange and tell the business user, oh, this is the real uplift impact from the Taylor Swift concert. That's pretty much how we use the time series to deliver our analysis and to answer the business question. Yeah, maybe this all of the uh simple use case that we use to analysis using machine learning to deliver our job. And one last thing that I want to emphasize is this is also I remember Bu Afia said about this. So using machine learning, uh using machine learning when simple logic works is like cutting a cake with a saw. It is possible, but it is just overkill. So you can use the machine learning when you really need it. So yeah, when the use case can be solved by a simple logic or simple method, just use it. But when you need more, you can apply machine learning. Okay, maybe I will stop here. Mm,
Yeah, thank you so much, Mbak Marisa ya. So insightful for the sharing and presentation. Yeah, I think all the students got new insight from the use case, many use case, and for me personally I also learn many things from your presentation. Anyway, for the maybe do you have still time for question answer, or because you you should have at
yeah. I
yeah.
think until 3:30 I can go off, yeah.
Okay, thank you. So for the question answer, maybe will be moderated by Mbak Nisat ya. Mbak Nisat, can you show on? Yeah.
Yes, ma'am.
Yeah, okay. Mbak Nisat is one of international student in master program of AI from Bangladesh ya. So Mbak Nisat, please moderate. So everyone, please let us know if you have any question.
Yeah, so everyone, please feel free to type your questions in the chat or raise your hand to speak directly. I will call on your name one by one, or I will help by reading out the questions from the chat. So please feel free to ask any questions. So no one have any questions? Maybe if there isn't any questions, can I ask one question to you, Ibu Marisha?
Yeah, can.
Thank you. So, in your experience working at Grad, what are some of the biggest like challenges you face when applying machine learning models in real world industry settings?
Okay, thank you, Nishal, for the question. It's a good question. So basically, the challenges that I facing when I try to apply machine learning is to understand the business context. So why understanding the business context is important? Because we cannot just maybe we can get a code from the internet, or maybe now we have ChatGPT to help us to build a Python code. But the very important thing is to do a feature engineering. And to do the feature engineerings, we need to understand about the business context. Uh, uh, what is the feature that needs to be involved to build a model and stuff like that. And because if we just put all of the features that we have, maybe it will lead to like overfitting or overfitting or underfitting. So by understanding the business context, it's very helpful for us to get a better model, to get a good model. But to understanding the business context is challenging because in Grab itself, we have multiple of business, multiple of product, multiple of feature, and the behavior across one product and another is different. So that's why actually the challenging part is to understand the business context itself. So it can help us to get a better output when we do a feature engineering. That's one thing. And the second one is maybe because we do the machine learning, we apply the machine learning to the real data. And real data is very dirty, very need to be clean. So running that data pre-processing is one of the important key also. Yeah, I think that's the two main challenging part when applying machine learning in my case. Yeah.
Ask you another questions as you mentioned about ChatGPT. So now people are saying you mentioned it yourself that ChatGPT can write codes in Python and any other language. So how do we distinct ourselves and how do we secure our own profession from ChatGPT coding?
Yeah, many people ask about this actually. I also sometimes get scared also about the ChatGPT, but we should not feel scared about it because it is really helpful for us to get better understanding in our scope in the how machine learning works also. But we also need human to interpret the result, to validating the result, and the prompt also coming from ourselves. If we didn't understand the problem, then we cannot write a good prompt to the ChatGPT, for example. And if okay, we can just type what we want in the prompt, but then uh to evaluate the result, we need ourselves, we need human to validate the result, right? So that's one thing that I believe the existence of ChatGPT is not something that scared us, but it is very helpful for us to learn more. And also usually I use ChatGPT to like brainstorming, because sometimes I have this idea and I don't have someone to talk with, for example, and I just trying to do ChatGPT to brainstorming my idea, and it becomes useful for me to have better approach when running an analysis.
Yeah, thank you. Thank you for answering my question. Is there anyone else who would like to ask any question?
Okay, I want to ask about, I do interest in machine learning, but sometimes I get confused from where do I start to learn it, either the theoretical first or jump into implementation. Okay, good question. So personally, I was also confused how to start, but obviously we need to understand about the basic one, but maybe not really theoretical, just a basic concept. And then the things that really helpful for me was do the implementation. So learning by doing is really important for me to get a better understanding. I don't know if it still exists or not, but back then I use a platform called Kaggle. So in Kaggle, we have like they have like open source data, and we can see other people post their answer, post their thought about how to solve this problem. So from learn from Kaggle, I really learn a lot about the how to implement the machine learning in the data, in the real data. So not too theoretical, but how to implement it in a real use case. So yeah, maybe if I can suggest, first you need to understand about the basic concept, and then try to implement it by exercising with some use case. Once you get experience, once you get used to apply this model to what use case, apply this model to what use case, this is very easy for you to, when it comes to a real use case, then you can easily, oh, just use it, just use it. Yeah, so learning by doing is the best one.
So, is there anyone who would like to ask another question? Does anyone have any other questions? So I think no one has any other questions, so we can finish it here. Is that okay with you? Do you want to add anything else to your presentation?
There is one question from Ken. I might want to ask question correlating to the use of analytical insight to be given to the product or company. What are the usual type of analytical data? Actually, it depends on the question. Yeah, it depends on the question, but usually maybe I said earlier that in data role, basic SQL is really important for a data role, because even though a sophisticated data scientist or machine learning engineer will be starting from collecting the data, and to collecting the data we need to apply SQL, right? Need to for data role, we need an advanced skill on doing the SQL data, because usually when it comes to the real problem, a quick question coming from the business or product, usually like for example, why our transaction is dropping last week. And to answer that, we need to collect the data first. So the basic one, you need to mastering the SQL part. And then to support your analysis, then maybe we can do first, if you cannot apply a simple logic to answer that question, then you can use machine learning to help you. So yeah, it depends on the situation. Also, one thing about dashboarding, usually for the major product or major business, we already built a dashboard. So it can also helpful for you to offer to the business or product teams, this is the data from the built data set that we already make it in the visualization in the dashboard. Yeah, maybe that's it.
Thank you. So do anyone else have any questions? You can ask one more question before you leave, so feel free to ask anything.
Maybe I also want to share with you about so there is an open internship program in Grab. Maybe
Yeah.
if you are willing to try, maybe you can apply. So this is the intern for GIP, Research and Data Analytics. So if you have interest in looking at the real use case in the industry, this is a best chance for you to try. I will share the link here.
I'm an international student, so I can do this, right?
Actually, you can do this also, because the requirement is only the minimum GPA, and maybe some of the college students